Hello, happy and smart developers. Welcome to the coding board. This is session 8 of C programming language. In this session, we are going to learn memory allocation. Memory allocation is an action of reserving partial or complete memory address space to store variables, instances of structures, and instances of classes of program for execution of programs and processes. Let me repeat once again. Memory allocation is an action of reserving partial or complete memory address space to store variables, instances of structures, and instances of classes of program for execution of programs and processes. Now, memory allocation can be achieved through memory management. Memory allocation can be achieved through memory management. Memory allocation is primarily a computer hardware operation. Memory allocation is primarily computer hardware operation, but it is managed through operating system and software applications. Now, memory allocation process is quite similar in physical and virtual memory management. Memory allocation process is quite similar in physical memory management and virtual memory management. Programs and services are assigned with specific memory as per their requirements when they are executed. Once the program has finished its operation and now program is in idle mode, then the memory is released and allocated to another program for their execution. If there is no another program for execution, then that released memory will be merged with the primary memory. Here primary memory is nothing but main memory or system memory. Now, memory allocation has two core types. Memory allocation has two core types. What are those? Static memory allocation. Second one, dynamic memory allocation. In static memory allocation is an allocation technique which allocates fixed amount of memory during compile time. During compile time only fixed amount of memory will be allocated, and the operating system internally uses a data structure known as stack to manage this. Let me explain. Static memory allocation is one technique of memory allocation in which fixed amount of memory will be allocated during compile time, and the operating system internally uses data structure known as stack to manage this. Now, memory allocation is done at compile time, means before program execution exact memory requirement must be known. Okay, memory allocation is done at compile time. At compile time means memory allocation will be done before program execution. So before program execution, memory requirement must be known in advance. Now, this memory allocation is fixed and cannot be changed. That is, cannot be increased and decreased after allocation. Variables remain permanently allocated. Memory can't be freed when it is no longer needed. Memory which is allocated cannot be freed when it is no longer needed. Now, in static memory allocation, no need to worry about memory allocation, reallocation, freeing of memory. Main disadvantage is wastage of memory, as there is a fixed memory which can be changed. Hence, it is less efficient as there is fixed memory which cannot be changed. Hence, it is less efficient. Why? Because if memory is fixed means it will not be released after its uses. Hence there will be wastage of memory. Now, example on static memory allocation. Let's say we have one array, integer array A with 10 elements, memory space. Then in Turbo C compiler, one integer value occupies 2 bytes of memory. Hence, total memory allocated for array A is 2 into 10. That means 20 bytes. So for array A of size 10 will get 20 bytes memory allocation. Now, if we use array A of size 10 like with element 10 and 20, then currently we are using 4 bytes only, but remaining 16 bytes will be wasted because at the time of compilation only 20 bytes were allocated for array A, and in static memory allocation we cannot increase or decrease memory size once it is allocated. Now, solution to above problem is dynamic memory allocation. Solution to above problem is dynamic memory allocation. In dynamic memory allocation, memory gets allocated during program execution time, means at runtime. For dynamic memory allocation in C language, we have powerful chapter called pointer. We will discuss dynamic memory allocation in detail in pointers chapter. That's it in this session. Let me recall once what is static memory allocation. In static memory allocation, memory will be allocated at compile time. Compile time means before execution time. So if we take an array of size 10, integer array of size 10, but we use only 4 bytes, then remaining 16 bytes will be wastage. The reason is the reason is at compile time only we have allocated 20 bytes, but we are using only 4 bytes. And in static memory allocation, once memory is allocated, then it cannot be increased or decreased. Okay, that's it in this session. Let's meet in another session. Thank you.